Welcome to chemistry class, your tutor Black Adam. So we're given the information about carbon, hydrogen. We have 0.0130 carbon moles, and then we also have 0.0390 moles of hydrogen and 0.0065. So we check which is the smallest, and 0.0065 is the smallest molecule. So we divide everything by the smallest to find the actual ratio. So it's 0.130 divided by 0.065, that's our smallest, and also dividing 0.039 by 0.065, and then dividing 0.0065 with itself, 0.0065, and then doing other calculation there, that will give us 2, and that one, then when you do your calculation, will give us 6, and then that one there is going to give us 1. So the ratio is 2, 6, 1. So carbon, we need 2 of them. Hydrogen, we need 6 of them. Oxygen, 1. So we don't include the number 1. And then next we have 11.66, that's iron, grams in ions, and then we have 5.01 grams in oxygen. And then we look at the values of iron, and then that's the molar mass there, and then oxygen molar mass. So what we do there, we have 11.66 grams multiplied by 1 mole over 56 grams. So for every mole there's 56 grams of iron. Then that gives us 0.208 moles. And we do the same for oxygen, that's 11.66. That's 11.6 divided by 56. And then from there, oxygen, we have 5.01 grams multiplied by 1. How many grams? 1 mole? 16. 16 grams, 1 mole of oxygen. And then that will mean that we have 5.01 divided by 16 to give us 0.313. So that's small. And then next, what we divide by the smallest, which is 0.208. So we divide 0.208 divided by itself. That will give us probably 1, absolutely 1. And then divide by 0.208. And then we do the same. That gives us 1. And then we're going to do the same for the oxygen, which is dividing 0.3131 divided by 0.208. That gives us 1.5. So looking at that 1.5, we write them in mixed fraction. So iron and oxygen, that is 1 to 3 over 2. So 3 over 2 is 1.5. So taking out the ratio, we divide both by 2, both sides by 2. So 1 times 2 gives us 2, and then 3 over 2 times 2 gives us 3. Okay, so that gives us 3. So it's 2, 2, 3. So we need 2 ions and then 3 atoms of oxygen. That's the ratio. And the next, which is the final question, which is C, which is 40% of carbon and 6.7% of hydrogen, 53.3% of oxygen by mass. So assume that there is 100, because if you look at other percentages there, it makes 100. So let's assume it's 100 grams. So 100 grams will mean that we have, for carbon, we have 40.08. So we convey the percentage to gram, making our assumption of 100 grams. So it's 40.0 gram multiplied by 1 mole of carbon will need 12 grams. So that is, our answer will be 40.0 mole divided by 12, and that gives us 3.33. That's moles. That's for carbon. And then we look at hydrogen is 1, so that would be hydrogen. We have 6.7 grams multiplied by 1 mole over 1. So over 1, that will give us grams cancels out, so it's 6.7 mole for hydrogen. Okay, 6.7 mole. And then we move on to oxygen. Oxygen, that's 16. So we come there, we say oxygen, and then we have that's 53.3 grams multiplied by 1 mole over 16 gram. So 1 mole over 16 gram, the grams cancels out, so we are left with 53.3 mole of oxygen. And once again, we look at the smallest. Okay, so 53.3 divided by 16 will give us 0.3131 mole. So we look which one is the smallest. Yeah, so that is going to give us 53.3 divided by 16, that's 3.33 mole. And then we divide by the smallest, which is 3.33, and that one also 3.33, and that 3.33, giving us a ratio of 1, 2, and 1. So 1 carbon atom for 2 carbon hydrogen, and 1 atom oxygen. So it's 1 atom carbon, and then 2 atoms hydrogen, and 1 atom oxygen. So that's the ratio. Alright, so thank you so much for watching, and don't forget to subscribe or follow. Thank you.